Now, what you've calculated just now is just the along wind concentration. This is the source at 100 meters. Y is 0 because it is based off of this line, and Z is 0 because it's at the surface. So 100, 0, 0. Notice that this X here is aligned with the wind direction. Now, if the wind direction change, then this coordinate system would also change according to the wind direction. Now, that is a problem if you want to do multiple calculations for many wind directions. So one problem is to set up your grid. So imagine a grid where you have your X, Y, and Z values set. But here it changes. So first we look at the wind direction, which doesn't follow the X, Y, Z. Then we calculate it. Then we transpose it, or we superimpose this alignment to the X, Y coordinate using the sin, cos, or the angle using the angle of the direction with the coordinate system. But what you calculated just now is whatever that is downwind from the source for that wind direction at that particular time only. Now notice that for you to do this by hand, even for one, it takes some time. So in air quality modeling, you need to do many. One for each hour of the day of the year for 5 years. So in the end, it's 24 times 365 times 5. So these are the number of calculations you need to do before you can combine all of them to get an average for a certain location. So definitely, you can do it by hand. There's nothing stopping you from doing it by hand, but it'll take a long time for you to do it by hand. For you to do it by hand, it's just like what you did just now. That's it. That's how you do it by hand. It's doable, but computers can do that very easily, very, very quickly for you. So that's why they code the equation here with the database, something like this. Of course, now they don't use this anymore. They use a different classification scheme. And then based on the condition, they generate the concentration for a certain location. And then that is for one location. What if you have a grid? Many points you need to calculate. So it's like 24 times 365 times 5 times how many points you have. Let's say 40 points. So times 40 some more. So that's one of the reasons why air quality modeling goes into being applied in computers instead of just doing it by hand. But at least now you know mechanistically how do you calculate it by hand. This is how you do it. It's just the scale. How many times you need to do it is the difference. So here, let me just talk a bit more about the mapping. Usually, when you run an air quality modeling project, you don't just calculate for one point. You calculate for many different points in the grid. And of course, the wind, like say the source is here, the wind direction changed throughout. So what I mean just now is that you have an XY coordinate like this. And then every time you calculate, it looks at the direction, right? And that is the new coordinate. But this direction corresponds to a certain point in the grid. So the trick is, although we're not going to go into that, is how do you translate this coordinate using this system into this coordinate system. And you do that just by knowing the angle and using, remember, sin, cos, to translate this coordinate system, this temporary coordinate system, to the main grid coordinate system. So you don't have to do it by hand because it's built into the model. You specify a grid, and then they will just automatically calculate it for you, the location of the points. I mean, they do it like this, and then they translate this point to the grid. But you don't do it by hand.